Good afternoon and welcome to today's industry-presented webinar, Muscle Cramping During Exercise. A few housekeeping things before we get started. This is a voice over IP webinar, meaning it's totally web-based. If you experience audio difficulties or if the video begins to buffer, it's likely caused by the strength of your internet signal. If you are having issues, try logging off and logging back on. If you have a question during the webinar, please type it into the question area within the GoToWebinar navigation, and we'll get to as many as we can at the end of the presentation. If your question goes unanswered, we'll take additional questions from today's webinar and post answers as a blog on the ACSM website at a later date. We also encourage you to join the conversation about today's webinar on Twitter by using the hashtags ACSMWebinar and GSSI. Today's webinar is presented by Gatorade Sports Science Institute. Founded in 1985, the Gatorade Sports Science Institute, or GSSI, is committed to helping athletes optimize their health and performance through research and education in hydration and nutrition science. GSSI scientists study the effects of nutrition on the human body before, during, and after exercise. For more than 2 decades, hundreds of amateur, athlete, elite, and professional athletes have participated in testing with GSSI and in studies with university research partners around the world. GSSI's headquarter lab, mobile and satellite laboratories, and on-the-field testing enable GSSI to do leading research with the aim to provide athletes with advice and products that help their performance and achieve their goals. One continuing education credit, or CEC, courtesy of Gatorade Sports Science Institute, will be emailed to all participants after the webinar. You should receive the CEC email and a link to the presentation within the next 2 to 3 days. There is no need to email ACSM asking about CEC credit. Today's webinar presenter is Dr. Maughan. Ron obtained his Bachelor of Science in Physiology and Ph.D. from the University of Aberdeen and was based in the medical school there for almost 25 years before moving to England. He is now visiting professor at St. Andrews University. He spent much of his career trying to understand the physiological responses to exercise and the nature of fatigue, but has included many digressions along the way. He chairs the Nutrition Working Group of the Medical and Scientific Commission of the International Olympic Committee and is a director of the IOC diploma programs in sports nutrition, sports medicine, and sports physical therapies. It is with great pleasure that we present to you Dr. Maughan.
Thank you for that introduction and welcome everyone. Thank you for joining me too to share our interest in the issue of muscle cramp. The title I have says, what's the cause and what's the cure? And I wish I could answer those questions, but we'll explore some of the issues at stake along the next 45 minutes or so. I'd like to begin by thanking the Gatorade Sports Science Institute for sponsoring this session and making it possible for us to get together and share our interest in muscle cramp. I should emphasize, though, that all the views and opinions expressed in this presentation are entirely my own. Cramp is an interesting issue, and it should be a simple one to address. It's relatively common, it's been around for a long time, and we should know some answers. If we are interested in prevention and treatment and we go to the internet, we can find many commercial products that are promoted either to prevent or to treat cramps if they do happen. These include a wide variety of different formulations. Many contain electrolytes, for example, sodium, potassium, often magnesium and zinc. Some contain vitamins, some contain buffering agents, some contain strong tasting substances and various herbal ingredients. If we look at the diverse nature of all these different products that are available, it seems unlikely they're all addressing the same causes. And that also makes it unlikely they can all be effective treatments for all types of muscle cramp. So we have then to address the issue first. What causes exercise-associated muscle cramps? There have been 2 main hypotheses proposed over the years, and sometimes these have run in parallel and sometimes they've diverged somewhat from each other. The most common belief that's prevalent in sport is that cramp is a result of some sort of disturbance of water and salt balance caused by exercise in the heat that leads to a spontaneous and uncontrolled contraction of the muscle. The alternative view is that there's a change in neuromuscular function, leading to an uncontrolled firing of the motor nerves. Of course, it's entirely possible that something else may be the cause. What that something else is, I don't know. The hypothesis relating to electrolyte and water imbalance has been expressed very eloquently by Mike Bergeron and others in a number of reviews. And they have addressed the literature and come to the conclusion that disturbances of water and salt balance are the most likely cause of exercise-associated muscle cramps. In his review published in 2009, Mike Bergeron said that maintenance of water and salt balance is the proven effective strategy for resolving and averting exercise-associated muscle cramps. If that statement is indeed true, it seems to support the idea that disturbance of water and salt balance is the fundamental cause of the problem. However, in a review published around about the same time, and therefore relying very largely on the same evidence base, Maughan from South Africa concluded that the scientific evidence that supports that belief, i.e. the belief that electrolyte depletion and dehydration are the cause of muscle cramps during exercise, come mainly from anecdotal clinical observations, from a small number of case series, and from a small case control study. And I think we'd all agree that that's not a very substantial evidence base. The alternative view proposed by Martin Schwellnus and his colleagues was that cramp is a result of some sort of disturbance of the control of muscle function. There's a change in the feedback from the muscle, leading to uncontrolled firing and therefore muscle cramp. The evidence for this hypothesis, according to Maughan in the same review published in 2009, is based on evidence from human models of muscle cramping, from epidemiological studies in cramping athletes, and from experimental data on animals, i.e. an altogether stronger evidence base than that supporting the dehydration and fluid balance hypothesis. So we need then to look at the evidence, because if we want to follow evidence-based practice, we have to be sure of the evidence that we're relying on. However, I think most of us would agree that practice, when it comes to cramp prevention and cramp treatment, often relies heavily on personal experience. It relies on the anecdotes of coaches, athletes, physiotherapists, and other support staff, and in many cases, a lack of familiarity with the published evidence. So the first question we have to ask is, what causes exercise-associated muscle cramps? To answer this question, we have to go back quite a long time in the published literature. And we have to look away from the studies simply of athletes or active individuals, and we have to look at people who are engaged in demanding physical exercise for prolonged periods in challenging environments. And it's not so long since many people, mostly men, earned a living by doing hard physical work in difficult situations. One such occupation is that of coal mining. It's physically demanding, it's often carried out at high temperatures and very high humidities, and it poses a number of risks to those engaged in this occupation. Not surprisingly, therefore, the medical staff who supervise the miners take great attention to the well-being of those individuals. And I'm going to go back to a paper published in 1923 by Neville Moss, looking at some of the measurements he made on coal workers and the issue of cramp in those individuals. He presents a very large number of tables of detailed measurements of people working underground. Here we see one table for one particular coal mine for one shift. And he measured the body mass before and after. And you can see from the body mass change in these individuals. In some cases, there were extremely high sweat losses. The American listeners will be very familiar with pounds for those not used to this somewhat antiquated unit of measurement. 19 pounds or 18.5 pounds is about 8.5 kilograms of body mass loss. So some of these individuals are sweating at very high rates and sustaining those sweat rates for very long periods of time. You'll notice too, though, there's a very large variation between individuals. In reviewing the evidence from many thousands of measurements over many years, Moss concluded that the causes of muscle cramp were associated with work in high air temperatures, with excessive drinking of water due to that high air temperature, and with continued hard work. He pointed out that most cramps occur during the second half of a shift, i.e. when the miners are suffering the effects of fatigue and prolonged working and are already substantially dehydrated. And he also pointed out that the muscles affected are those engaged in the work, and that those who suffer from cramp are generally not in good physical condition. To further investigate these issues, he contacted J.S. Haldane, one of the leading physiologists at the time, and Haldane suggested that cramp may depend on excessive loss of chloride as a result of large volumes of sweat being lost. Today, we normally think more about the sodium loss, but at that time, it was easier to measure chloride in blood and urine than it was to measure sodium. So the focus was more on chloride losses than on sodium losses. But we know today, of course, that these two go very closely hand in hand. In order to investigate it, Haldane sent his son, JBS Haldane, who later gained fame as a geneticist, the author, Neville Moss, and A.V. Hill, who had won the Nobel Prize for Medicine and Physiology in 1922 for his work on muscle physiology. They went down the coal mine and made various measurements on the workers in the mine. They collected urine samples, and they found that there was very little chloride in the urine, whereas normally when the urine volume is small, we'd expect a high chloride and high sodium concentration. So this was a somewhat surprising finding. In summarizing the evidence, Haldane wrote in the British Medical Journal in 1923 that men working in hot mines suffer greatly from a sensation of thirst, which appears to be in part due to drying of the mouth and throat. They are therefore induced to take large quantities of water, so large as to be in excess of the real requirements of the body. So this is not dehydration, rather it's overhydration. He went on to say this cramp is a form of water poisoning of the muscles, brought about by a combination of great loss of chloride, also sodium by sweating, excessive drinking of water, and a temporary paralysis of renal excretion. That almost exactly describes the situation that occurs in hyponatremia associated with exercise as a result of excessive ingestion of plain water in combination with loss of sweat. So I think this is a very prescient statement by Haldane made in 1923. I move now across the Atlantic to some of the work done by Bruce Dill and his colleagues looking at people in various industrial settings. They studied workers in the great dam constructions carried out in hot, challenging situations. They also looked at a number of other industrial settings, one of which was workers in the steel industry, which was both physically demanding and carried out in very hot environments. Again, huge numbers of measurements were made on workers over a period of many years, and I show this table not to focus on any individual values, but rather to point out that detailed measurements were made over prolonged periods of time, looking at changes in body mass, looking at the volume of fluid consumed, the volume of urine produced, the specific gravity and the chloride content of the urine, and a whole range of other measurements. So these were very detailed records kept on these individuals. And you can see in some of these individuals, there are very high water intakes and extremely low volumes of urine being produced. If we look halfway down the column roughly, we can see one individual ingesting 11 litres of water and producing only 1 litre of urine. Clearly, there's a very substantial amount of water going somewhere. Whether to sweat or somewhere else is not entirely clear from these data. Dill reported that when measurements were made on some of the steel workers who did experience muscle cramp, they found that the plasma concentration of both sodium and chloride were low, and indeed so low that little was being excreted in the urine. This is not the situation we'd expect with simple dehydration, where the plasma concentrations of sodium and chloride both increase substantially due to the loss of hypertonic sweat. This can only occur if there's a substantial ingestion of plain water in excess of the volume of fluid being lost in sweat. In assessing the picture that they saw when they assessed individuals who had experienced muscle cramps, they said that they saw dehydration, they saw a lowered concentration of sodium and chloride ions in blood plasma, which is not what we'd expect with dehydration. They found little or no sodium or chloride in the urine. They found an increased serum protein concentration, which is consistent with dehydration and hemoconcentration. An increased red cell count, again consistent with dehydration and hemoconcentration, and perhaps somewhat surprisingly, a normal osmotic pressure of the plasma. We would expect, if there was severe dehydration, to see increases in sodium and chloride and increases in the osmotic pressure. Here we see a fall in the concentration of sodium and chloride, but a normal osmotic pressure being maintained. In terms of practical input, because that's why Dill and his colleagues were invited to study these occupational tasks, they said that they provided to the mill workers water with added salt. And they said that they added a concentration of 0.1%, which is quite a strong and strong tasting saline solution. They indicated there was considerable reluctance from the workforce to follow this procedure. The men didn't want to drink the salty water. During the initial period, they reduced it during the winter, but they increased the concentration to 0.1% during March. That's a pretty salty tasting drink. In spite of that, they said the only complaints came from workers in another steelworks who wanted salt added to their water, as was done in this experimental situation. That seems somewhat surprising. So why did the men in the other workplace want salt added to the water? Well, they looked at the results, and we see that in 1935, they said the results were very favorable. The mill where water was given to the men with added salt was the only one that worked throughout the summer. There was not a single case of heat exhaustion or cramp in the mill the whole summer. That seems somewhat unusual given the record of the industry. They said that during the next 12 months, with 12,000 workmen, there were only 22 cases of heat illness, 11 with cramps, and 11 with heat exhaustion. This compared with previous years when as many as that number sometimes were sent home in 1 or 2 days. And they pointed out that in the previous, 2 years previously, in June 1933, in 1 day, 12 men were hospitalized due to cramp. So it seemed that adding salt to the water, a very simple intervention, was extremely effective in preventing the incidence of cramp. Given the complications, the issues related with cramp, the interference with productivity in the workplace. There were a considerable number of other studies in the 1930s and 1940s when the military began also to be interested. Many reports were published over the next few years, and I cite here only one from 1938. And I cite this because they compared a patient group with a control group who worked in a similar environment but who did not experience cramp. In the patient group, there were 17 with heat cramps and some with heat exhaustion and heat stroke. In the control group, there were a total of 43 physically similar individuals. Those suffering from cramp showed hemoconcentration, which is consistent with dehydration. But again, they also reported a decreased serum chloride concentration, whereas we would normally expect to see an increased chloride concentration if we simply had dehydration. The only situation in which this can occur is if the loss of sweat is accompanied by the ingestion of large volumes of plain water. So the picture that emerged was indeed one where dehydration was common, where there was a large loss of sweat, but instead of being dehydration with disturbances of salt balance, we see a situation where there is rather a dishydration, a disturbance of water balance, often with a hemodilution, at least as indicated by the electrolyte concentrations. I'm going to jump forward about half a century, and I'm going to show the results of my one and only study, my experimental study on the issue of muscle cramp. This was a fortuitous study. We set up an experiment to look at temperature regulation and fluid balance and performance in a group of marathon runners. These were individuals competing in the Aberdeen Marathon in 1983. There were 100 volunteers who took part in the study. Half of them were given water to drink at every feeding station, and the other half were given the same volume of a dilute carbohydrate electrolyte solution. The plan had been to compare the effects of these two different solutions on a range of physiological and biochemical parameters. As it happened, 15 of the 82 subjects for whom we had full data experienced muscle cramp, and we took advantage of this opportunity to compare those who experienced cramp with those who didn't. We could see no difference in any of the serum biochemical measurements that we made between those with cramp and those without cramp. And this has been reproduced in a number of other situations. And this is often used as evidence to say that disturbances of water and salt balance are not the cause of muscle cramp during prolonged hard exercise. However, we need to bear in mind that mostly the blood samples obtained in these situations are not obtained at the time of cramping, but some considerable time afterwards. In this case, all these individuals managed to finish the race. And we also need to bear in mind that the measurement of electrolytes in blood may or may not reflect the local changes occurring within the active muscle where cramp occurs. So although the results of these studies are often used to say that disturbances of water and salt balance are not a cause of muscle cramp, I don't think we can fairly draw that conclusion. One other piece of evidence came from a study from John Stofan and his colleagues. They looked at American football players, some of whom experienced cramp quite frequently, and they matched them with a cohort of teammates who never experienced muscle cramp. They assessed fluid intake during training and sweat loss during training, and they saw no differences between the two groups, between those in those two different measurements. What they did find, though, is that the sweat sodium loss was much higher in those with cramp versus those who didn't experience cramp. So again, a suggestion, although not entirely convincing, that disturbances of salt balance may be a factor implicated in cramp. So my conclusion from that side of the evidence is that there is more evidence than just anecdote and a few case studies, that cramp has been shown to be associated with hard physical work in hot environments, and it has been shown to be associated with large salt losses and sweat, but accompanied by the intake of large volumes of plain water rather than simply as a result of dehydration. I mentioned the second primary hypothesis, that of altered neuromuscular control, and a very elegant schematic has been produced indicating the mechanisms that may contribute to these changes in control of the muscle function which lead to cramp. The first part of the argument is that repetitive exercise, i.e. prolonged hard work, especially in a hot environment, but not necessarily a hot environment, leads to muscle fatigue. That muscle fatigue in turn leads to an increased excitatory afferent activity from the muscle spindles and to a decreased inhibitory activity from the Golgi tendon organs. These two together are likely to result in an altered firing pattern, which will result in loss of control of the muscle and an uncontrolled spasm of cramp. The idea that cramp may be nervous in origin rather than purely muscular was promoted as a novel idea, but in fact, as with many things, if we dig back through history, we can find it's not as new as we might think that it is. And I show here a copy of a report from a UK government committee which looked at cramp in telegraph operators. It's easy to forget that in the days before the internet and telephone, communication was largely by Morse code, signals sent down a wire, and large numbers of people were employed as Morse tappers doing repeated contractions of the small muscle in the finger in order to operate the Morse tapper. These people frequently experience muscle cramps, as do others with similar occupations such as typists or writers. And this, of course, was a problem for those who relied on Morse code telegraphy as a way of communication. So the UK government commissioned a report. That report, published in 1911, reviewed the evidence on muscle cramp, at least cramp as it affected these small muscles in the hand. They said some people regarded it as a muscular disorder, others as a disease of the peripheral nervous system, others as a disease of the central nervous system. They reviewed the evidence and they concluded that this type of cramp was a disease of the central nervous system. So once again, if we look back through the literature, we can find some early pointers that perhaps it's not entirely a muscle phenomenon, but something occurring in the nervous system. The altered neuromuscular control hypothesis, as promoted by Martin Schwellnus, was supported by evidence of an association between factors causing premature muscle fatigue and exercise-associated muscle cramp. I have to say that I've never found it easy to understand what premature muscle fatigue is and how it might differ from other types of muscle fatigue. But I think we can accept that muscle fatigue is a predisposing factor to muscle cramp. Martin said there's good scientific evidence that fatiguing muscular exercise can cause muscle cramping, and I think we would all accept that. And also pointed out that there's scientific evidence that the mechanism by which fatiguing exercise causes cramping is an altered neuromuscular control. So I will look briefly at the evidence for these statements. In a paper published in 1996, i.e. before the development of this hypothesis, or leading to the development of this hypothesis, Martin pointed out that in a large-scale cross-sectional survey of marathon runners, over 1,300 marathon runners, they were asked about their experience of cramp and the factors that might have contributed to that muscle cramp. About a quarter of the runners reported that they had experienced muscle cramp, and more than half of those indicated that muscle fatigue was associated with and preceded the onset of exercise-associated muscle cramps. I think we have to be cautious about accepting this, though, because it would be very surprising if anyone managed to finish a marathon without muscle fatigue. And indeed, we have no indication of the state of fatigue of the runners who did not experience muscle cramp. I suspect it was perhaps not greatly different. There was a paper published in 1957 looking at the ease with which cramp could be induced before and after a period of exercise. In this situation, a group of college students were asked to shorten the muscle and maximally activate it. And if you want to try this, and you're welcome to do it just now, shorten one of your muscles, perhaps the biceps muscle, and try to maximally activate it, or the gastrocnemius muscle. In a shortened position for the gastroc, i.e. with the foot extended, try to maximally activate the muscle. And a number of people who do this will find that they experience cramp relatively rapidly. In this situation, about 18% of the subjects experienced cramp before they did a period of exercise, and that increased to about 26% after the exercise. So the numbers able to induce cramp were quite small, but they did increase when the effort to induce cramp was preceded by a bout of exercise. The second point was that fatiguing muscular exercise can cause cramping, but as I've already alluded to, I think towards the end of a marathon, everyone is severely fatigued, but typically no more than about 10 or 20% of runners experience muscle cramp in that situation. So clearly, although fatigue may be a contributing factor, it cannot be the only factor, or everyone would experience muscle cramp. There is a large body of evidence suggesting that changes in the motor control mechanisms influencing muscle as a result of fatigue will result in a number of situations that may predispose a muscle to cramp. And this is supported by good scientific evidence. The problem, of course, is that the spontaneous cramps that afflict athletes are almost impossible to study prospectively. After the marathon study that I alluded to earlier, that we published in 1986, we spent a lot of time recruiting volunteers who said they always got cramp when they ran. We brought them into the laboratory, collected blood samples, made various measurements, had them run on a treadmill. No one got muscle cramp. So it's almost impossible to study these spontaneous cramps in a prospective study design. Instead, therefore, people use a range of different laboratory models. These include low-frequency nerve stimulation, which will induce muscle cramps, particularly if the muscle is held at a short length. And as I mentioned earlier, a sustained voluntary contraction, again with the muscle held at a short length. The lowest electrical stimulation frequency at which a muscle cramps is termed the threshold frequency. And there is good evidence that this correlates with predisposition to cramping. But I should emphasize that these laboratory models, although useful for the study of cramp, may differ from the cramps that afflict athletes. A number of studies have been carried out using these models, and one in particular has been used as evidence that hypohydration is not a cause of muscle cramp. In this study, a number of individuals were studied before and after dehydration, and the threshold frequency for inducing muscle cramps was not changed by substantial dehydration, about 3% reduction in body mass. This, therefore, seems good evidence that dehydration is not the cause of cramp in this situation. However, we should note two things. One, that this is hypertonic hypohydration. The plasma sodium concentration was increased, not decreased, as reported in the earlier studies. So these people were simply dehydrated and did not ingest sufficient water to result in a fall in the plasma sodium concentration. And secondly, these studies do not directly measure muscle cramp, but rather the susceptibility to cramp in response to an electrical stimulation. So there's a substantial body of evidence that's consistent with the theory of altered neuromuscular control, and this comes from many different sources, looking at fatigue, looking at the susceptibility to cramp, and it's consistent with the theory, but that in itself does not prove the theory. And the experimental models on which it's based may not represent the spontaneous cramps that afflict athletes. However, we should recognize that using those experimental models, there are some more recent data, very recent data, this one from 2018, looking at the voluntary contraction model and looking at the effect of dehydration caused by sauna exposure. In this situation, individuals were dehydrated by 1, 2, or 3% of body mass in response to heat exposure. When they were studied with no dehydration or with 1% dehydration, nobody was able to induce cramp by activating the muscle in a shortened position. 3 of their subjects got cramp when they were dehydrated by 2%, and 6 of their subjects got cramp when they were dehydrated by 3%. That's out of a total of 9 subjects in the study. So these results were interpreted as suggesting that dehydration does increase the susceptibility to muscle cramps. And more recently still, published last year, and the title of this paper tells us everything. Water intake after dehydration makes muscles more susceptible to cramp, but electrolytes reverse that effect. So in this situation, individuals were dehydrated. They then drank either water or an electrolyte containing oral rehydration solution, and cramp sensitivity was measured by the electrical stimulation, looking at the threshold frequency for induction of cramp. The muscles were more susceptible to cramp if water was consumed, but if an electrolyte containing drink was consumed, they were not more susceptible to cramps. So the picture is not entirely clear, but we should note that the exercise-associated muscle cramp is only one form of cramp. There are many, many other kinds of cramp that may or may not have the same underlying causes as the cramps that occur during exercise. One common factor in many of these is disturbances to metabolic profile or to water and salt balance, particularly the cramps that occur during renal dialysis, for example. If we don't understand the causes, there are clearly implications for what we can do to prevent muscle cramp and what we can do to treat muscle cramp. And depending on which of the theories you subscribe to, you might recommend different interventions. If we look on the internet, there's no shortage of suggested remedies. As I mentioned before, water, magnesium, but also things like pickle juice, mustard, quinine, and vinegar, all of which are noted for their very strong taste, and a wide range of different foods that are promoted for preventing cramp. Again, I would emphasize these are not exercise-associated muscle cramps, but the cramps that spontaneously affect many people, including especially older individuals. Quinine is something that's commonly recommended. A Cochrane report looked at the evidence. They found 23 trials with more than 1,500 participants, and they found some evidence, but not very strong evidence, that quinine may reduce the cramp number and cramp days, but I suspect most people would not want to take quinine on a prophylactic basis. They looked at a range of other non-drug therapies, and the conclusion they reached was that the studies that had been carried out were too weak in order to draw any meaningful conclusions. So for anyone who's interested in pursuing the issue of muscle cramp, the field seems to be wide open to investigate these different therapies. So in conclusion then, exercise-associated muscle cramp is a form of muscle spasm that occurs during or within the minutes or perhaps even hours after exercise. But we have to recognize that it's only one of many different types of cramp. The causes and therefore the treatments are not well understood. If we can find out more about the causes, we may be in a stronger position to recommend some effective treatments. It does seem to be the case that disturbances of salt and water balance are a contributing factor in at least some cases of muscle cramp, although there may be others in which they are not related to water and salt imbalance. And there does seem to be evidence that the most effective treatment for affected muscles is stretching, which perhaps offers some support to the idea that the disturbance between the inputs from the muscle spindles and the Golgi tendon organ are disrupted. Stretching the muscle will, of course, change the afferent input to the central nervous system and may disrupt the pattern of firing that's causing the muscle cramp. So a couple of take-home messages to finish. Cramp is relatively infrequent, although some individuals do seem to be particularly susceptible and experience it much more often than others. Usually it resolves spontaneously within a few minutes. It's therefore often dismissed by the medical profession as something that's trivial and unimportant. But of course, if you experience cramp in a competitive situation, it can be the end of your Olympic dreams. We could say, perhaps with some confidence, that maintaining water and salt balance may reduce the risk of exercise-associated cramp, at least for some athletes. Perhaps not for all, but there is reasonable evidence that for some individuals, there may be a reduced risk. We might say that those prone to cramps may need to work harder on maintaining their hydration, on improving their fitness, their strength and flexibility. And we might say that although many different formulations are promoted for prevention and treatment, the evidence base for, I think it's fair to say, pretty much all of these is not entirely convincing. But we can conclude that some may work sometimes for some athletes. The message therefore is, if you think it may help, it's worth a try. And perhaps I should leave the last word to John Scott Haldane, and again his paper in the BMJ in 1923. He said, as regards prevention of symptoms due to excessive removal of chloride by sweating, all that was needed was a sufficient supply of sodium chloride. By eating red herrings or highly salted bacon, coal miners usually prevented the occurrence of these symptoms. And if stokers in hot climates at sea would add about 1/10 of seawater to the water which they drank during work, just as the coal miner added about 1/4 of 1% to his water or tea, or would eat plenty of salt meat or fish, they could also prevent the symptoms. Thank you very much for your attention.
Dr. Maughan, thank you very much for the presentation. Very informative and interesting. We had a lot of excellent questions come in from our attendees. So we do have a few minutes that we can take some of those now. I'm going to start with combining a few questions with similar subject matter. Does warming up reduce the risk of developing muscle cramping? And related to that, will regular stretching reduce the risk of muscle cramping?
Those are two separate questions. The first issue on warming up, I think there's absolutely no evidence that warming up will have any effect on muscle cramping. Having said that, that's based on anecdote and hearsay. There have been no comprehensive studies, and the reason for that is, as I pointed out, it's almost impossible to carry out prospective studies looking at exercise-associated muscle cramps. There is some evidence that stretching may be a useful part of the armory for those who often experience muscle cramps. The evidence isn't entirely convincing, I don't believe, but if I was someone who was prone to muscle cramps, I would certainly say it's worth a try. It's unlikely to do any harm. There are some reports that those who stretch may experience cramp more often than others, but there are also some reports saying that cramp is not associated with stretching habits. It's a try it and see situation, I'm afraid.
Okay, thank you. Our next question, does age relate to the risk of muscle cramping?
If we're talking about non-exercise associated muscle cramp, then age certainly does play a role. Cramps are relatively common in old people. I used to think that doesn't really matter, but I'm now in the position where most of my students think of me as an old person. So I have to start taking that as a little bit more seriously. In terms of exercise-associated muscle cramps, I think there's no good evidence of an increased predisposition with age. So again, that's perhaps a difference between the exercise-associated muscle cramp and other types of spontaneous cramping.
Question, if you can give me just a second. What is the best protocol to manage and advise an athlete consulting for recurring muscle cramps episodes?
That's the million-dollar question. Cramps very frequently, and some indeed find their careers being ended because they simply cannot tolerate the cramps that afflict them every other training session. I think it's a question of looking closely at all the factors that might work, and looking at hydration, looking at salt, looking at drinking behaviors, but also looking at stretching behaviors, looking at everything you can think of, looking at the different remedies that are available, and trying to see what works. Sometimes you just find something that works for some people. Not very scientific, I know, but that's based on experience of speaking to athletes who've had problems. And sometimes if they try enough different strategies, they'll find something that works. And sometimes they just find they stop spontaneously.
Okay, interesting question. Are athletes with short muscles more likely to cramp than athletes with longer muscles?
The short answer to that is I don't know. By short muscles, presumably we mean muscles that tend to be tighter. I don't think anyone has looked at that, as far as I'm aware. I maybe have missed something in the published literature, but I'm not aware of any evidence. So I think you can get the idea that there's plenty of research potential still in this field, and I would encourage those taking part in this discussion to really think about where there might be opportunities to carry out some research that will help us solve the problem.
Excellent. Next question. Would the body temperature affect muscle cramping? Can overheating the body during prolonged exercise be good or bad for this phenomena?
In the early days, muscle cramps were often called heat cramps because they were most often experienced by people working in hot environments. But we know that you can get cramp in cold environments too, and you can get cramp when sweat losses are quite small. So I'm not sure that temperature is a major factor. if we look at this again, if we look at the situation in a mass marathon, we see people who finish one alongside the other. We can probably figure that temperature's not hugely different between those who get cramp and those who don't. In the study that we did with a small number of cramping subjects, the number on whom we had cramp reports and also core temperature at the end of the race was too small to tell us anything meaningful. But again, we had the situation where measuring core temperature at the end of the race doesn't necessarily tell you anything about what core temperature was at the time of muscle cramps. So somehow we have to find a study design where we can look at people perhaps doing an ultra endurance event on the track, where we can get immediate access to people when they have muscle cramp and make some meaningful measurements. Again, fantastic research opportunities.
Okay, next, in your experience, does pre-exercise electrolyte drink decrease exercise-induced cramping?
I don't have enough experience to answer that question, and I would say we need to be extremely cautious, because it would depend on whether you started out dehydrated, normally euhydrated, normally hydrated, or overhydrated, and what your electrolyte status was at the time. So as with most things in life, too much is just as bad as too little. And I think there's an issue when people start taking salt tablets, for example, and I know that they're sometimes recommended before exercise when people are doing prolonged exercise, if they're susceptible to cramp. The danger with salt tablets is it's easy to take too much. So I think you need to be a little bit cautious. Equally, you're unlikely to do any serious harm, so try it and see what happens.
Okay, possibly a related question here to your salt tablet reference. Attendees are seeing ultra endurance athletes taking magnesium tablets. They believe that it works in ultra races and such. What do you suggest to them?
Magnesium has been popular in ultra endurance events for many years, and interestingly, it's much more popular in Germany than it is in most of the rest of the world. And I don't really understand the reason for that, unless there's a commercial factor driving that. The answer is, again, we simply don't know. The evidence we do have suggests that in people who have recently experienced cramp, there's no major disturbance of the serum magnesium concentration. There's a little bit of evidence suggesting that those who are prone to cramps, who frequently report cramps, do not have different baseline serum magnesium concentrations from those who don't get cramps. But again, there are limits to the interpretation we can put on a serum magnesium concentration. So the answer is, we don't know. But I'd go back to the answer, so long as you don't overdo it, it's unlikely to do any harm. And if it works for you, fantastic.
Excellent. We talked a little bit about warming up and stretching. We've had a couple of questions come in regarding massage. Can you elaborate upon massage or associated activity like foam rolling to address cramping before, during, or after the onset?
The problem during or after is that it's almost, if you have a good going muscle cramp, it's almost impossible to do anything apart from lie down and scream. You're not able to do much with the muscle with a full-blown cramp. So the only intervention that seems to work, at least most of the time in that situation, is stretching of the affected muscle, even though it can be extremely painful. That does seem to work. In terms of other interventions, we simply don't know. Again, the Cochrane review dealing with exercise associated cramp, dealing with other forms of cramp, did not find any convincing evidence on any of the usual therapies.
Okay, thank you. We had a few questions come in regarding genetics as well. Would an individual's genetic makeup have anything to do with susceptibility to cramping?
There's another great research project for somebody, possibly several for somebody's. And again, I give you the same answer. I simply don't know. It's not hard to imagine that there would be some link. Equally, I don't think it's a simple, straightforward link, so it's unlikely we would find a genetic pattern that would give us a clear answer. So I guess I'm saying no, I don't really think so.
Okay. Is there any evidence that muscle cramping can be damaging to muscle tissue?
Oh, I think undoubtedly there's damage to the tissue. You know, it's a full-blown contraction of the muscle, and it hurts. It would be very surprising if you didn't cause some damage to the microvasculature, to the muscle membranes. Once again, those things can be measured quite easily. I'm not aware that anybody's looked at markers like CK or LDH in the plasma after cramp. Fairly simple to do. Another great research project would answer one of those questions. Does it have any practical implications? Perhaps not. But it would be an interesting addition to what we know about muscle cramps.
Okay. And a question regarding acupuncture. Have you seen any evidence of acupuncture helping with cramping?
No is the short answer, and no is also the long answer. Again, it's not difficult to imagine that if you made measurements on enough people, you'd find some who reported a benefit from acupuncture. So again, it's not likely to do any damage. If it works for you, great.
Very good.
There seems to be a recurring theme I'm saying over and over again. I don't know. And at one time I would have worried about that, but in most of these cases, I don't think anyone else knows either. We just don't have answers to these questions.
Well, we appreciate you sharing your expertise and the body of evidence. Tremendous presentation. This should be a good time for us to wrap up. You've taken many questions already. We actually have captured many more. And for the attendees, I will say that if your question was not answered, we will be submitting additional questions to Dr. Maughan, and we'll be posting those at a later point on acsm.org as a blog. So watch for that to be coming at a later point in time. And with that, we'll be wrapping up today's presentation. Thanks again to everyone for attending. As a final reminder, an email with a link to your CEC, along with a PDF copy of today's slides and a recorded version of the webinar, will be sent within the next 2 to 3 days. Within that email, there will also be a short survey, and we'd appreciate your feedback on today's session so we can continue to improve. Thanks once again to Dr. Ron Maughan for the presentation and for handling all of the questions, and to GSSI for supporting today's webinar. Have a great afternoon, and that will conclude today's webinar.